what we're going to look at today is matrix multiplication. So this is different to what we were looking at last lesson, where we were multiplying matrices by a scalar. So you know how last lesson we were either doubling each value in the matrix or we were halving each number in the matrix. In this chapter, 14C, we're actually going to be multiplying two matrices by each other. So matrix multiplication. Alright, so basically what we can do is if we have two matrices such as this row matrix and this column matrix, we can multiply the matrices by taking this first value and multiplying it by that value, plus this value times this one, plus this value times this one. So see how they've gone 3 times 1.3, then they've added 4 times 0.9, and then they've added 2 times 1.2. So we'll just go through it a bit slower here. So if A is equal to 3, 4, 2, and B is equal to 1.30, 0.90, 1.20. Alright, now, before you can multiply any two matrices, there's some conditions that need to be satisfied. So you know how we're talking about order of matrices? We talk about how many rows and columns they have. So this matrix here has 1 row, 3 columns. So the order of that matrix we say is a 1 by 3. Remember how we use that terminology? So the order of A is a 1 times 3 matrix. And then the order of B is a 3 by 1. Now, for us to be able to multiply any two matrices, these two numbers here have to be the same. So because I've got a 1 by 3 and a 3 by 1, I'm able to multiply those matrices. But if I had a 1 times 2 and this was a 3 by 1, I can't multiply those, right? Because that 2 and that 3 are different, we aren't able to do it. The resulting matrix will be a size, then you look at these two values, a 1 by 1. So when we finish doing our multiplication, we're going to end up with a 1 by 1 matrix. Alright, so you first need to look at, are those two values the same? If yes, then look at these two values and that will tell you the size of the resulting matrix. So if I want to do this multiplication, A times B, or AB, is equal to, I'll just write out the values again, so 3, 4, 2, and B is 1.30, 0.90, and 1.20. Now you're only going to get good at these by practicing a lot of them, right? Because it takes a while to get your head around them. So, like I said, we take this first value, we go 3 times the top value there. So we go 3 times 1.30, then we add. We go to our second value. This one multiplied by this value here. So it's going to be 4 times 0.90 plus, we take our third value, 2 times 1.20, which is equal to, now this is just a matter of simplifying that matrix, so you could just use your calculator to do that, but it comes out as 990. See how it's just one value? It's a 1 by 1 matrix. So how is this useful? So maybe you want to purchase some items. We've got 3 cans of soft drink, or we're going to purchase 3 cans of soft drink, 4 chocolate bars, 2 ice creams. So our matrix is 3, 4, 2. So that's talking about the quantity of things that we're going to buy. And then this second matrix is our cost matrix. So the soft drinks are $1.30 each. The chocolate bars are 90 cents each, and the ice creams are $1.20 each. So once we've done that matrix multiplication that we just did, can you see that it's going to tell us what the cost of those total items are going to be? Because we had 3 soft drinks at $1.30, 4 chocolate bars at 90 cents, and 2 ice creams at $1.20. So that $9.90 that I worked out was the total cost of buying all of those items. Alright, now we're going to have a go at a multiplication which is a little bit more complicated. So this is example 5. So this time, A is going to be equal to 135. B is going to be equal to 1, 2, 3, 1, 5, 3. And C is going to be equal to 1, 0, 2, 3, 1, 4. Alright, with all of these questions, the first thing you need to do is check the order of each of these matrices. So hopefully we're comfortable now in saying what the order is. So this matrix here is a 1 by 3, 1 row, 3 columns. So the order is 1 times 3. This one here, what's the order of this one? Good, 2 by 3. And then the order of this one, 3 by 2. So remember, if we want to see if we can multiply 2 matrices together, the numbers need to match up. So would I be able to do a multiplication of A times B? See how that's a 3 and that's a 2? I cannot do that multiplication. That would not be possible. But then, if I was to look at this one, B and C, this is a 2 by 3 and this is a 3 by 2. See how those two numbers there are the same? Therefore, I can do that multiplication if I wanted to. And the resulting matrix will be size 2 by 2. And I'll show you how you get each of the different components. So, we'll start off by doing A times C. So we're going to go this matrix times this one here. So first, let's check the order. This is a 1 by 3, this is a 3 by 2. Is that multiplication possible? Because they both have a 3 there, it's possible. And the resulting matrix is going to be a 1 by 2 matrix. So, I'll write them out. We've got 1, 3, 5 times this matrix here. So we've got 1, 2, 1, 0, 3, 4. I'll just pause it whilst you copy it. Like I said, since this is a 1 by 3 and this is a 3 by 2, since those numbers there are the same, we can do this multiplication. And the resulting matrix is going to be a 1 times 2. So 1 row, 2 columns. So, it's going to be 1 row, 2 columns. Alright, now this is the tricky bit. And you only get good at this by practicing lots of them. So we start with this value here. We go this value times that value there. So we go 1 times 1. Then we go to this value. We go 3 times 2. So plus 3 times 2 plus 5 times 1. Alright, so I'll repeat that. I started with this value. I went 1 times 1 plus 3 times 2 plus 5 times 1. And that's my first component of this 1 by 2 matrix. So remember, because it's a 1 row 2 columns, that's our first input or our first component. Now we need to work out what our second component is going to be. So I go 1 times 0 plus 3 times 3 plus 5 times 4. So 1 times 0 plus 3 times 3 plus 5 times 4. So can you see that I've got those two separate inputs, those two components? So that is going to be a 1 by 2 matrix. Now it's just a matter of me simplifying each of them. So it's just bed maths. So 1 times 1 is 1, plus 3 times 2 is 6, plus 5 times 1 is 5. So that's going to be my first input. And then my second one, 1 times 0 is 0, plus 3 times 3 is 9, plus 5 times 4 is 20. So this is equal to 6 plus 5 is 11, plus 1 is 12. And 9 plus 20 is 29. So our resulting matrix is 12, 29. Remember what I initially said? When we look at the order, the 1 and the 2 should be our resulting matrix, a 1 by 2 matrix. Have I been left with a 1 by 2 matrix? Yes. So I know that I've done that correctly. So the next multiplication we're going to do is B times C. We're going to do BC. So remember, check the order. This is a 2 by 3. This is a 3 by 2. Because those are both 3's, can I do the multiplication? Yes. And the resulting matrix is going to be a 2 by 2. Alright, so I'll just do it here. So BC is equal to, so first I'll write my matrix B, 1, 2, 3, 1, 5, 3. Times my matrix C, which is 1, 2, 1, 0, 3, 4. Alright. So our resulting matrix, like I said, is going to be a 2 by 2. So always keep that in the back of your mind, so you will end up with 4 different components in that matrix, because it's a two row, 2 column matrix. So how do I do this? I start off, now this one's getting a little more complicated because there's 4 inputs. So I have to go 1 times 1 plus 3 times 2 plus 5 times 1. And that will give me my first element. Alright, so I go 1 times 1 plus 3 times 2 plus 5 times 1. And that will give me my first component of this 2 by 2 matrix. Then I look at this row, this column. So 1 times 0. So that one times that one, plus 3 times 3, plus 5 times 4. Alright, so first I took that row and multiplied it by that column, then I took that row and multiplied it by that column. Now, remember, because the resulting matrix is going to be a 2 by 2, so I still should have 2 more elements underneath. I haven't multiplied this bottom row by anything yet, have I? So I'm going to now multiply this bottom row by that column, and that will give me this input. And then I'll take that row and multiply it by that column, and that will give me my final component. So I go 2 times 1 plus 1 times 2 plus 3 times 1. Alright, so I've just multiplied that row there by that column there. So the only row and column that I haven't multiplied now is this bottom row by that column there. So I'm going to go 2 times 0 plus 1 times 3 plus 3 times 4. And now it's a matter of simplifying each of those components. So 1 times 1 is 1, plus 3 times 2 is 6, plus 5 times 1 is 5, 1 times 0 is 0, plus 3 times 3 is 9, plus 5 times 4 is 20, and then 2 times 1 is 2, plus 1 times 2 is 2, plus 3 times 1 is 3, and final one, 2 times 0 is 0, plus 1 times 3 is 3, plus 3 times 4 is 12. And that would give me 6 plus 5 plus 1 is 12. 9 plus 20 is 29. 2 plus 2 plus 3 is 7. And 0 plus 12 is 15. So just have a go at doing 1A, B, and C. These, remember, always check the order first. So this matrix here is a 1 by 2, that's a 2 by 1. So since the two are the same, we can do that multiplication and the resulting matrix will be a 1 by 1. This is a 1 by 3, that's a 3 by 1. Again, we can do that multiplication and the resulting matrix will be a 1 by 1. And then this is a 1 by 4 and that's a 4 by 1. Again, we'll be able to do that multiplication and the resulting matrix will be a 1 by 1. Then we'll have a go at doing a few more difficult ones in tomorrow's lesson.